Okay, you're welcome to class group today. My name is Jude Chukwudi Ilebelu, your facilitator. Today is the day 9 of our Python class vis-a-vis machine learning and other aspect of our teachings. So we are going to focus on exploratory data analysis, normally referred to as EDA. It's a very important topic that you must pay attention to if you are to make headway and important success in data analysis and Python. So EDA is an essential step in the data science workflow that involves understanding and exploring the data before applying any modeling or analysis techniques. So what is simply saying is simple, that it is not enough for us to have data, for us to have our Jupyter notebook by our side and we have data and we open it and we are happy that we are data scientists. Something more differentiate us from others. Remember, it's all about having insight, seeing what others cannot see, and using it to make important recommendation to stakeholders, which will turn around business, which will improve decision making and make system better. So before you apply any model, you must have first of all have looked into your data with an eye of EDA. So its primary purpose is to gain insight. 1, to identify patterns. 2, and dictate potential issues in the data set. So data on their own is nothing. It is what we make out of data that differentiates it, that makes it outstanding. You can have a lot of numbers scattered everywhere, it makes no meaning. It is when you arrange them in a way that we can be able to understand pattern, read interpretation, and use it for decision making. So some aspect to consider. So basically 4 aspects are for us to consider while we're talking about this: data collection, data pre-processing, data cleaning, data visualization. All of them make up data exploratory analysis. So for data collection, talks about where do we source our data, in what form is the data, and how do we put them into use. Data processing, how to do some kinds of manipulative capabilities as a data scientist to prepare our data before we start the main work of processing it. Data cleaning, how to remove a lot of null values and make it workable. Then visualization, you use some tools, some plotting, some graph, some visual tools in order to bring it into speed. So what do we actually do under the exploratory data analysis? There are basically 6 things we can do. So one of them is to collect the data and gain domain knowledge. So when you collect the data, you can know what type of data you are using. When you know such, it directs your thoughts and your attention to what you want to do. The second one is to confirm data types. Remember, data are not the same, and they are supposed to be in a particular type that must be usable. If you have a float or you have an integer, you know this is a float, an integer, or you have a text, you should know and how to basically best apply them in your work. So you confirm data types and their probabilities. Then the third thing you do is to measure of central tendency. We have mean, mode, median. These are simple central tendency that defines our data to know if they are normal data or skewed data. So it's part of what we do. Can calculate the mean, can calculate the median, amongst others. Then the fourth thing you do is to measure of dispersion. When we talk about dispersion, we're talking about the deviation from the normal mean, or the mean, the average. When you move away from average, by what proportion? That is what we're looking at. We look at it in terms of variance, standard deviation, and range. Then the skewness, right or left. You know whether the data is skewed to the left or skewed to the right, because there are tools you can also use to make them better and normal. So, but we need to know where the problems are coming from in order to effect such correction. We know we know thinner peak, wider peak, whether the peak is very, very thin or whether the peak is very, very wide. We should be able to determine that under this process. Then the last one is graphical representation. We're able to plot histogram, board plots, bar plot, dot, stem, scatter plot, anything we can be able to do in order to visualize our data is part of what we do under the EDA. So the next thing we do, now we are going to look at those things we just discussed in details. So for data collection and familiarization, get yourself acquainted with data. First of all, you collect relevant data from various sources. You understand the data structure, the variables, and their meaning. So looking at it, we can determine whether we are collecting or whether we have collected, or what we are collecting is either a primary or a secondary data. Primary data are data we source ourselves. We can source it through different means: statistical method, through survey, through poll, interview, DeFi techniques, focus group, amongst many. Now for the secondary data, we can use reports, various reports like financial reports, sales reports, government reports, mission report, vision statement, internet. These are the data we did not generate ourselves, but from other important sources which we can also use for visualization or for interpretation or for whatever purpose we deem fit. So the second thing we do is data cleaning and pre-processing. So when we talk about processing, it means the actual analysis of data through different stages, but processing is what to do before we start processing our data. It is also important. Remember, I said that data are not always clean on themselves. They have a lot of issues when you bring them up, whether they are primary or secondary. It doesn't matter. It is on rare occasion you have a data that is very, very clean. So you need to put some things in order. Excuse me. So you should be able to know how to handle missing values. We can either use imputation or removal. When you use imputation, we are trying to look for things that we can use to make the data complete, rather than removing everything that has to do with a data that is not complete. In the last class, I'm talking about null value, empty set, and system cannot analyze empty set, so we need to either remove it or we impute it. So we identify and handle outliers and abnormalities. So for outliers, we are looking at those values that are at extremes. Those ones, they always make our work spurious. So we always find a way to address outliers. So we standardize or normalize variables if necessary. So the work we have, we always find a way to make them normal. We use standard procedures to make them normal, and also we standardize them so that they can be on the same scale. Just imagine you have a scale of income in millions, and you're having maybe another scale of something else that is in thousand, and they are supposed to be on bar chart. Consider the million will dwarf the thousand. It will not make our work look spurious. So we should find a way to make them to be on the same scale, so that the graph or the graphing can be made better. Encoding categorical variables. We should be able to know what is a categorical variables, and able to, when we have categorical variables, those variables that, for instance, male, female are categorical variable. Whether you attribute number 1 or number 2 to male, or number 1 or number 2 to female, does not make one superior to the other. It is just number we put by just assigning. So those numbers are categories. So we know how to encode them so that we can be able to bring them into analysis. So for data cleaning cycle, we should be able to know how it works for data cleaning. When you want to clean data, you can start from any of this process. Any stage is okay to start. So assuming we're starting from importing of our data, when you import data, the next thing is to look at data sets, how they look like, and possibly know how to match some data sets. So if you can be able to have data sets that are scattered, you can merge them, then you can rebuild and able to establish missing data and see how to fill up missing data, or how to address issue of missing data. Then you put them to standard. They should be on the same standard. Put them to standard that expected, the level that is expected. Then you make them to be normal. Normalize the data. Then you remove duplicate, because when we have duplicate, it does not help our work. So we'll find a way to remove our duplicate. Then we can do verification of our work and enrich them. Sometimes we'll go ahead to even do feature engineering to our work. Then now we'll export the data and put them safe, or we can see continuing the process. This is the process of data cycle cleaning. Now for descriptive statistics, for instance, to be able to know how to calculate summary statistics, mean, mode, and median for numerical values. So numerical values are values that has numbers. They don't have text. So because they have number, we can be able to apply calculation to them. We determine the distribution of our variable to know whether they are normally distributed or not. And now we examine the correlation between variables. It's very, very important, because when variables are correlated, analysis becomes difficult. So we must be able to determine what is the level of correlation, and if possible eliminate it, so that the variable should not be correlated, for us to get a proper result. Look for the example given to us here: mean, mode, median, and range. When we see, we have 1, 3, 4, 6, 6, 7, 8. So for us to calculate the mean, we'll add them up and divide by the number, and it will give us 5. And for us to look at the mode, we say class with the highest frequency, and that is 6. So the median is the middle mark. 1, 2, 3, 4, 5, 6, 7. That is still 6. And the range is from the first one to last one. So you say last minus the first. That will give us the range. So data visualization, which is an essential part of data science, is very, very important in exploratory data analysis. Remember, we're talking about looking at our work before we start our work, giving us insight, giving us direction, helping us to understand our data in order to make an interesting view or interesting input into our work. So data visualization will create visual representation. We can use plots, we can use charts and graphs to understand our data. We will explore the distribution of the various or the variables through histogram, box plot, amongst others. We use scatter plot to analyze relationship between variables. You can see this is an example of a histogram, and it helps us to see where the distribution is. We can determine whether this is a normal distribution or not. And from what I'm seeing here, this is not a normal distribution. You can see that it is skewed. It is skewed to the right. So it is this exploratory data that will help us to do that. So we'll now look at the implication of this if it is skewed to the right. We can also use box plot. This box plot and whisker and violin plot to ascertain our work too. So we can be able to have picture. This is an example of plotting. Can also use pie chart, scattergram, as the case may be, in order to also understand our work. So the fifth thing we do is improving our work, feature engineering. So in feature engineering, we can decide to, within our given data that we have, we can decide to improve by creating new data, by combining or by using multiplicative capability on our data to generate new ones and use them too in order to get better understanding. So we derive new feature from existing one to enhance predictive power. So whatever we have, we can add to it. We can transform our variable for better representation. For instance, we put them to log transformation. We can extract useful information from text or time-related data. So for hypothesis testing, we formulate and test hypotheses about the relationship or differences in the data. We utilize statistical tests. We can use t-test, ANOVA, chi-square, as the case may be. Now the seventh is iterative exploration. So under iteration, we'll continue to improve our work from an initial standpoint. Continue to do things, we can add and remove and observe and see how it impacts on our work. So we'll continuously explore and refine insight based on initial finding. So iterate between data cleaning, data visualization, analysis. We'll continue to work within as we are cleaning, we'll continue to clean the data, add more things to it, visualize it and see how it looks, and make analysis and come back again. So it's iterative exploration until our aim is to make it better, to get the best out of our work. It's not all about just jumping in and jumping out. It's making it to be better. So with number 8, we'll talk about documentation and reporting. So document finding, insight, and step taken through EDA should be able to be written down to guide our work. Remember, most of the work we do is not only for ourselves, it's for stakeholders, it's for our company, it's for our colleagues, it's for the community. So whatever you have done, somebody can be able to also go back and see it, so they can be able to improve on it. So you know how to communicate results effectively to stakeholders, because if after you have done all this, remember this data science work is not something you just do overnight. Sometimes it takes months to achieve appreciable results. So if after all this you cannot be able to communicate your results to understanding of stakeholders, then you see that you have not done anything. The people that are supposed to take decision based on your finding should be able to understand what you have done, at least in a simple language that they can be able to make decision. Now we have advantages and disadvantages of using exploratory data analysis. The advantage is that it gives us valuable insight into data. We see more things about data that ordinary eyes cannot see. 2, it helps us with feature selection. So like I said, improving on our work using PCA. I've forgotten the full meaning of PCA, I'll get it later. Visualization is an effective way of detecting outliner. But if you look at different form of dimension, whether 2 dimension or 3 dimension, help us to reduce our work. Disadvantage of EDA is one, if not performed properly, it can misguide a problem. When we don't look at issues critically, we can misguide what we are doing. We end up not getting any meaningful result. Secondly, EDA does not affect is not effective when we deal with high dimensional data. So high dimensional data is those data that have many variables. That is why in machine learning, most time, even if we have about, for instance, we have 10 features or 20 features, we cannot use all features to make our analysis. It becomes too sensitive for working. That means it has high level of dimension. We'll find a way to reduce it to barest minimum 5, 4, highest 6, that has impact on the work, so that we can be able to make predictions that can stand the test of time. So it's when we have high dimension data we're not able to make anything out of it. Remember, EDA is a creative and interactive process that requires your curiosity, your critical thinking, and open mind. It helps you understand the data better. It helps you to identify the challenges ahead and makes informed decisions for subsequent steps in your data science project. So this is just a cursory of what EDA is. We shall be putting them into practice. I will be sending some notes that have to do with EDA too, so that to enrich your library and also enrich your capability of handling assignments. So in addition to our EDA, the exploratory data analysis that we just learned, we also need to visit and work on the list. When it comes to removal, I tried to do that day using POP, but I didn't do it well, so I want to revisit it and treat it very, very well for your perusal. Then you can also look at how to treat errors and exception in Python. Then you know we have finished with our basis for Python. It doesn't stop you from further studies, further research and investigation to know more and to earth out more of what you need to know, because this our study is endless. It's endless. You can't finish it even in 1 year. So want to learn how to remove items from a list. So let's come down and use our removing items from a list. Run it. So we can remove items using these 3 important methods. You can use the del method. You can use the pop method, and you can also use the remove method. There may be possible other, but this is the 3 I want to touch. So for the del method, okay, let's come here and create a space. given that you have my list, and my list has the following items. It has shoe. My list has wrist watch. My list has tie, socks, shirt, boxer, trouser, let's just add one more thing, maybe a cap, okay, cap, and then lastly sunshade. So this is what is contained in my list. So I can run it to commit to memory. So if we have that, now I want to use the del function. How do we do it? So for the del function, you need to specify, for the del function, you need to specify the position of what you want to remove. You need to specify the position of what you want to remove. So for instance, looking at these items, I want to remove my tie. I want to remove my tie from this list. Now you have to look at the index position of tie. You start from here, it is 0, 1, 2. So tie is in position 0, 1, 2. So you come here, you write del, which is the function. You want to delete my list. Then you put up your bracket and say, which is in index 2. So once you have done that, and you write my list to see what is left, and you run it, you see that shoe, wristwatch, socks, tie has been removed. We have been able to remove an item, but we need to specify the index position in which the item we wish to remove is located. So for using the pop, using the pop now, the pop method. How do we remove an item using the pop method? The pop method removes an item, but it has a peculiar way of removing an item. Unlike the delete that you specify the position, pop always remove the last item, the item at the extreme right. That is what, if you continue to click on pop, it will continue to remove until your set becomes empty. That is how pop works. But now, how do you write your work in order to remove this item? So what you do is, my list is the name of the list that contains this item. So you need to specify a particular name of what you want to do as you are removing your item. So you say, for instance, removed item. That is the defining what you want to do. And you are removing item from what? my list. My list is where the item is. So you do my list dot pop and you put up the bracket. So this is what you have done. Now, when you have done this, you want to see the item that was removed. You can either click my remove item. So let's run this and see. First of all, to see if it run. Now it has run. Remember, the last item is sunshade. So if I come now in this line of code and I write removed item, it will help me to see the item that was removed, and I run it. It says sunshade was the item that was removed. That means sunshade is not more here. So, and I come again to run my list. Let me see what is remaining in my list. My list. And I run it. You see, cap now is the last item that I can see here. So sunshade has been removed. So if I decide to run this my list again, under this pop, it will remove the last item again. So let's try something and see. Let's write my list again and run it and see. Okay. Now if you use this line of code and bring it down and run again, it will remove this cap. Now let's see. You just remove item and you copy it and you come here and do Ctrl V, and now you come down and you write my list, taking note that my cap is the last item, and we'll run it. See, cap has a remove remaining trouser. So when you continue it in that manner, you continue to remove the last until your set becomes empty and error will be thrown up. So the last method that we indicated here is remove. So using the remove method to eject or to remove an item in our list. So how does that work? So remove, unlike the first one that looks for index position and the other one that removes the last item, remove works with the name of the item you want to remove. It's possible, you know, an item is existing in your list, but it's possible you don't know the location or the position in which this item is located. But once you know the name of the item, it is always possible for you to use the remove function to do that. So how do you do that? You write my list dot remove. That's the code. Then you will now bring in your bracket and now bring in the item you wish to remove. Which item do you want to remove? Irrespective of the position, I want to remove socks. This is the item I wish to remove. And when I finished it, I would like to see what is remaining in my list. And I now run. Now discover that socks was after wristwatch. Now socks has been removed. So this is how you can be able to remove an item using either of these three um, um, procedure in order to achieve what you have in mind. Okay. So the next thing we want to do now is to look at errors. Errors and exceptions in Python. It's an important learning that you need to bear and put in mind as we continue to study Python and its application vis-a-vis machine learning. So you ask yourself, what are errors? If you have been observing what we have been doing of lately, you see that as we are coding, errors will always be popping up. And if you are a novice to application of Python and coding, you will be thrown aback. You will become frustrated. You will want to give up. But it's not supposed to be like that. Errors, when they come, it means that what you have thrown into the system does not understand, or it tried to decipher it, but it's not making headway, or it's thinking that what you're supposed to do, you are not doing it in the required direction. So it will throw up an error. These errors are always in two shades. One is the actual error, and the other one will be exception. We have runtime error and error that are there when you have impute. Sometimes you impute something correctly and it will throw up something that does not look like what you have done. So what I really want to do today is to touch it in brief. There are plenty of them. We don't need to know everything now, but at least you have to have idea of these errors. Having idea is one thing, and how to go about it is another thing. Once time an error throws up, 90% of most of our error are keyword error that comes because of our write-up. We may write something with misspelling error. It's very, very common. Like last time I was trying to type column and didn't type it well, and because I didn't type it, even if you miss a letter, it will throw up an error. When you don't use your space very well, it's possible to throw up an error. So I want to use this time to see if we can be able to pick up some errors, and we look at them. So for one of the error we can see is arithmetic error. You can see arithmetic error. Arithmetic error. So what are arithmetic error? These are error, and in arithmetic error you can see something like floating point error, floating point error. You can see overflow error, overflow error, floating point, the way it appears, I want it to floating point error, overflow error, And then you can also see zero division error. You can see zero division error. This is error you can see in arithmetic when we have arithmetic error that have to do with calculation. When we have to do with calculation, once any of this is touched, you can see that appear. The next error you can see is assertion error. Assertion error. Maybe I'll number it so that is number 1. The next one is number 2. Assertion error. Then we can also have number 3, attribute error. Remember when we're talking about attribute physical quality. So when you are writing and those qualities are not there, attribute error will pop up. We also have number 4, buffer error. We have another one, number 5, EOF error. We have number 6, import error. Import error. And then for the import error, mostly what you see is module not found error. Module not found error. So here you want to import a library and you're not importing it well. This import error will pop up telling you that you are not doing it well. The problem most time we have is that we don't take time to look at what the error that is coming up, and we tend to fret, and that makes it more difficult for us. So the next one is look up. This one is look up error. Look up error. So for look up error, we'll have some things to look at there. It may be index error, where the index is not properly defined. Index error will come up. We will also have key error. Key error. So the next one, number 8, we'll have what we call memory error. Memory error. We also have number 9, name error. Especially when you have defined a variable and now after defining the variable, you are not calling it properly. You are calling it wrongly. So it will give you that. Most times you see unbundle, unbound, local error. That's what you see. We also have number 10. We also have number 10, which is a operating error, OE, operating system error, where the system itself is not allowing you to do anything. So once they come, you now know what to do. For the operating system error, things like this may prop up. We have blocking IO error, blocking IO error. You can also have something like child process error. When you are dealing with inheritance, you will see those ones. Child process error. You can also see connection error. You also see connection error. So under the connection error, for instance, you can see further error. It's under OS error, and OS error, you have connection error. We still have other branches, such as a broken pipe error, broken pipe error. You see connection aborted error, connection aborted error, connection reset error, then under OS error, you can still have file exist error, file exist error. We have file not found, file not found. We have interrupted error. You still have other ones like is a directory error not a directory error? We have permission error. We have process lookup error. Process lookup error. We have timeout error. We have it's number 11. We have reference error. Number 12 as runtime error. Runtime error. And for runtime error, we have not implemented error. Not implemented error. We have recursion error. Recursion error. We have number 13. Syntax error. For syntax error, we can see something like indentation error. Indentation error. For indentation error 2, you can see something like tab error. Number 14, we have system error. System error. Number 15, we have type error. Number 16, we have value error. And for value error, we have something like Unicode error. And for Unicode error, we can see have something like Unicode decode error. You can also have Unicode encode error. You can also have Unicode translate error. Then we have this, you cannot really call it an error, but it is an important tool that is very, very helpful so that you can be able to know what you are doing. We call it warning. Warning is very, very vital and important. The reason is that we'll see it now. One, it will come in this way. Deprecation warning. Deprecation warning will tell you that this particular line of code that have been provided you have been using will possibly become extinct or not in use in Python anymore. So you need to begin to look at the new code which they will also give to you. So if you have an old code, you can either translate it or do what they have asked you to do. The next one is pending deprecation code. Pending deprecation warning. This one is still hanging. It can come anytime. Now we have runtime. We have runtime warning. We have syntax warning. And still going to come back again to look at this. It's not all of them that we're going to look, but it's good you have it. Then there are some that are always repetitive. User warning. We have future warning. We have import warning. We have Unicode warning. We have bytes warning. We have resource warning. So we have resource warning. Now we also want to look at some exception. Because exception are another important aspect that we must not overlook. Say number 18. Say exception. Or say base exception. Base exception. So for base exception, we have things like, let me give it to gap. For base exception, we have things like system exists. System exit. We'll have keyboard interrupt. We'll have generator exist. Then we'll have exception. Exception. And for exception, we can have things like stop, iteration. We can have stop, sync, iteration. We can have sync iteration. So this so we'll use our MB convert to run it, so it will remain. So we can look at it again. So these are some of the codings error we will likely encounter when we are running our Python. Most times you will not see all this error, but this is general error you can see anytime in Python. But in most time and most cases, you may likely not see them. So you don't have to always be fidget about it. For arithmetic error, for instance, discover that people that are mostly into arithmetic calculations, they may fall into arithmetic error. When you have floating point error, overflow error, zero division error. When you have not used the numerals as expected, some of this error will throw up. So assertion error and assert error, you will see them. Attribute error always comes up because when you are not giving proper attribute, when you are not defining your class, your method very well, attribute error may likely come up. You can also see EOF error when what you are trying to code, sometimes the library or the data you want to call up is not well, it's either not in your system. So because it's not in your system, you are calling it up and you want to run it, this EOF error will be throwing up. Now for import error, you know, Python itself has self-built libraries. That means there are already libraries that already are imputed as the Python environment is brought forth. So they're there. You can also add other libraries. When you use pip install, which I will teach later, you can also use pip.conda. It's an open source, but pip install is mostly good for Windows. So when you use it, you can bring in new libraries as you wish, and they will be in your Python, your own Python environment. Now, it is one thing to have them and another thing to bring them to your place of work. When you want to work, when you see I was trying to do NumPy, I did what I say, import NumPy. When I wanted to bring in pandas, I say import pandas as PD. What I'm doing is that those libraries that are already in the system, I am bringing and calling them to use them for my work. Even though they are in the system, if I don't call them, they will not be used. So when I don't call them and I start to use pandas, for instance, it will tell me that I have not done what? Imported them. So this import error will show up. So normally once the error comes up, it helps you to do what? To know what you have not done and now see how you can do it and get your right answer. So you can see when you put that import error, when it comes up, most times you say module not found error. So what you want to do is not found because you have not imported it. So it's not there, even though it is in the library in your environment, but you have not called it up for use. So we have lookup error, we have index error when you are not using the index properly. Remember when we are trying to call our list, we start from index 0, index 1, index this. So once you are calling something and you are using a different index, it will prop out index error. We have key error. Sometimes we see it as key value error. So those errors have to do with the values that you are putting. Memory error, maybe once your memory space is not available or adequate, memory error can drop up. Name error, when you are not using the names, especially the spelling, is not done very well, you'll be seeing name error. Part of what you see there is unbundled local error. For number 10, we see operating system error. So that is the system itself. The system you are using may throw up error even as you are trying to use Python. So it will show you OS error, and some of what you see, blocking IO error, child process error, connection error may come up. For connection error, you can see broken pipe error, connection aborted error, connection result. This is for the operating system, and we can have other ones that can also come up under this. After connection error, can have file exist error, file not found, interrupted, amongst others. We have reference error, runtime error. When the time allocated is cannot be able to give you what you want, the runtime error may come up. Now we have syntax error. So some of the error you see most time, you see attribute error, you see name error, you will see syntax error. Syntax is when you didn't put the right in the position of your work, or when it is not called very well, or the right calling is not done. Syntax error will show up. For the syntax error, you can something like indentation error. That means the indentation is not done very well. If you were observing when I was typing, there was a time a red line came up. That red writing that came up didn't come by fancy. It came up because I have shifted the work in the way that the system does not want. So if I have not left, for instance, if it is a code I am doing and I shifted that work and I run it, it will give me what we call syntax error from the main indentation error, because the indentation has shifted. Once you put that double colon, when you come the next line, it will not start from the initial point, from the end point. It will always give a space. So that space is supposed to be respected. You look at it from local and global variable calling. So it looks as if you want to make a local variable declaration. So it is different from global, where it will start from the extreme, especially left position. So when we have done that, it will give us indentation error, and to correct it, like when I shifted it again, it comes back to black color. That means it has been corrected. Then you can be able to run it. Such thing can happen if you have a very long line of code and I did not give the proper indentation. I'm telling you, you will not get any answer. It will keep you there until you're able to do it well. That's why sometimes, most time, we encourage people to copy and paste. The way, if a code has been run before and it got an answer, even if it's somebody's code you are copying, copy it well to get the same replication of answer. It is a science. By the time you have become an expert, a guru, you can begin to write your own code, but it starts from small. But for now, most time, copy what you have seen and adopt it in your own environment and run it. If the code runs, you are going to get the same answer. So we have tab error. The tab, when you look at your laptop, after escape, the down part, then followed by tab. The tab has two arrows. One is pointing inside, one is pointing outside. Once those positions are not obeyed, tab error will come up. Then we have system error, we have type error. That type error has to do with the type of data you are using. Are you using integer? Are you using float? Are you using strings? Any of those things, when you misuse them, type error will come up, especially in a place where the data type is of importance. So when you don't code it well, you see your type error. They are all on there. You can also see for the type error. Then the next, you can also see value error. And for the value error, it can be Unicode error, and the Unicode can come under Unicode decode or encode or Unicode translate error. Then for warning, warning is an important element when we come to our coding. Warning helps us to look at some future elements that may either deprecating, that means they are being removed, or they will be replicated, or they are no more in use. So most time when you are running a code, those ones that has issue, Python will be giving you a lot of write-up that does not make sense. It makes your work look clumsy. So what you normally do is do what? You import warning. You can see there's a place to import warning. You import the warning and you put it up and you put it in place true, so that when such things come, even though it's going to happen, it will be suppressed such a way that it will allow you to do your coding without having a lot of challenges. So warning is very, very important. Some of the warning will be deprecation warning. They are telling you this code, this line of code you are using will not be effective soon. In the next, maybe the codings you have run that gave you answer, after 6 months, after 1 year, after 2 years, when you come back and you run the same code, you may possibly not get the same answer again, or it will throw in up error. The reason is that those line of code has deprecated. They have changed it, they have improved it, or they have changed the source. So because of it, you have to, but it's not something you'll be afraid of, or that will be painful to you. Just follow those errors and you see there will be a suggestion of what you may do. So copy those new suggestion line of code, replace it with what you have in your code that you have run before, and you run it, it will give you the new answer, and that answer will be correct. So that is what it's all about. You see pending depreciation warning, some that are still pending, but they know definitely it's going to change. Then we'll have runtime warning, so that there's some work that you do for those code to run, they may take up to 1 hour. So you have to put up those runtime warning so that it will not have any issue at its running. User warning, future warning, import warning, all those warnings are there, so you don't have to run away from them. Then the exception base, you have system exist. Exception is you may write a code and the code you have written is semantically correct. It is well written. There's no element of error, but you see that error will pop up. Sometimes when those error pops up, you write a code of exception. So that exception will let you know that what you have done is wrong. It is right, but because of that system issue, you will not tell you, okay, the code will tell you if it doesn't work the way you want it, or because you have set it very well, it's giving error. So instead of writing error that you don't like, you will not say, okay, this not found, yet to be approved. That kind of English word that you write as a piece of code. And when you run it, when we have such exception, it will not give you system not running, or you have to do this, or you have to do that. And once you have done what, it will now come as if there's no error. Meanwhile, that exception has taken care of that error that came up. So it can be under these things you are seeing here. Stop iteration, stop async iteration, amongst many. So I hope you have learned. We cannot completely exhaust the topics under the Python, but we have been able to touch the basics, the ones that will help you to build still strong foundation. And we encourage you to study, visit books, visit internet, take our baseline and continue to explore. When you have questions, please don't fear to call on us. We come and we look at it together and we build together. W3 School should be your companion at all times. So in the next class, we'll be entering into machine learning proper. We'll start with introduction as usual, and we'll learn the basics, and we'll start our project. So I'll be excited to see you in our next class. Have a wonderful day, and may knowledge be on your side. Bye bye, and God bless.
In today's world, data is the new gold. Data scientists unlock insights from raw information. They use statistical methods to analyze trends. Data analysts convert data into visual stories. By creating dashboards, they help organizations make informed decisions. Machine learning models can predict future outcomes. They identify patterns that aren't visible to the naked eye. Data cleaning ensures accuracy and analysis. Collaboration across departments enhances data insights. They utilize programming languages like Python and R for analysis. Cloud computing resources expand their capabilities. With big data, they tackle complex challenges across industries. Ethics in data science ensures responsible use of information. The future of data science looks bright with endless possibilities.